Hi everyone, welcome to Data 2030 Summit. I'm here to give a brief lecture on digital transformation and data and insights aspects of it. So, let's just start with an introduction about me. I've been in BA and analytics space from last 11 plus years, expert in cloud and digital transformation. I worked in various industries with various domains like shipping and digital marketing, etc. And I'm very expert in latest technologies like big data and data science, etc. So my hobbies include painting and filmmaking. My recent movie was Lost Einstein. It's on Amazon Prime. You can watch it when you have some time. So now let's get into the topic. So digital transformation. This is the most common word we have been hearing these days. Yet most of the people doesn't have a proper definition of what it meant. So there is a misconception that digitalization is seen as digital transformation, but which is not. So let me just explain you this with a simple example. Let's say we are taking a notes on a paper. I mean, we used to take notes on the paper. So when a group of people are working together, discussing and brainstorming on something, a person is taking notes on a paper. So in his company, in his business model, the idea is he will take the notes on the paper and he will go back to his team and take actions based on the notes he has discussed in the meeting with the high level executives. So let's say this is the business. So instead of taking the notes on the paper, if you start taking the notes on the electronic device using through some app or any web app on the laptop, so that is called digitalization, wherein you have some inherent advantages, like the notes will be forever for you to refer. You can search after many years. Also you can search by the keywords so that you'll get exactly what you discussed on the day, which might not be the case if all of your notes were in the paper. And you can share. These are the advantages you have. But this step is not just what the digital transformation meant by because this doesn't change. This have not changed any of your activities of the business. It doesn't change any of the ways you respond to your customers, but instead the capability of taking notes electronically. This is the technological feature. So the digital transformation aspect of it is, for example, you're taking the same notes in the meeting, but simultaneously that was synced to your team and they are taking action simultaneously even before you have not completed your meeting. This is digital transformation, wherein your mode of operation, your method of working, the way you serve your customers or whatever it is, your operations have changed, which means it's transformed because of the digital technology you have. That is what digital transformations. So digitalization has to happen first before the digital transformation. So if you see lots of the ERPs and other software tools which have started in 1940s, 50s and 70s, that was part of the digitalization. But currently now we are in a phase of digital transformation. In short, digitalization is a technology adoption, wherein digital transformation is innovating the business model, innovating the business using the technology to your advantage. In order that to happen, You need data, insights, and prediction capabilities. And you need to drill more into the data so that it enables you to transform digitally. Let's get into more details on this. Any organization's survival or innovation depends on the decision it makes for its future growth. There are two kinds of decision generally any organization would like to make. One is strategic decisions and another is operational decisions. A true digital transformation happens whenever strategic decisions becomes data driven and operational decisions become event driven. So for example, based on your strategy, let's think like stocking your warehouse based on your historical data over past few years for a specific event happens, like a festival or a uh, Christmas, something like that. So the strategy is defined by the data, underlying data you have. For the operational event driven decisions, let's say an example like you are rerouting the stocks from the different warehouses into a specific warehouse depending on a random event that occurred on that specific year or a day, something like a storm or heavy rains. So there the your operational decision was taken based on an event. So generally the operational success influences your strategic priorities, and strategic vision influences operational priorities. In both these cases, you need the data, you need the analytics to get the insights out of it and take an action. So now let's get into more details to discuss the nature of the data in these two domains. So when it comes to strategic, mostly it is being used for predefined metrics, to develop long-term insights. Whereas the operational kind of data is used for building automated processes. Something like the example which I have given in the previous slide, based on a heavy rainfall, taking some decision to read out the packages. And the strategic data drives the long-term insights and like quarterly planning, etc. But operational data is actually used for real-time responsiveness, and it drives the instance interactions. So on a whole, the strategic data, a high level data, historical data, determines the business strategy, wherein the operational data, the insights we get from the operational data, we can use it for getting the new business opportunities, innovating the business models. Regarding the time sensitivity, we'll discuss the more details in the following the slides. But in short, uh, the time sensitivity is low when it comes to the statistical questions, because we don't take it's not like we need it in a day or immediately. But when it comes to operational, the time sensitivity is very high. If the opportunity is lost, it's lost. So this is more time sensitive. So this is where nowadays we are concentrating to get excel at to get this kind of information, time sensitive insights and analytics using the big data and IoT. So now let's get into the value of the data. So operational value of the data drastically reduces over the time, whereas strategic value increases over the time. Sometimes the underlying raw data can be same underlying raw data can be used for both operational and strategic purpose as well. but still the context is different. So the real-time data from event sources provide a high value and the opportunity only in a very small window. If you take the graph here, in the x-axis it's the days or the time. In the y-axis it's a value it generates to an organization. So if you see the operational value of any data, it reduces and drops to zero over a few days. But the strategic value of it actually increases from then, and in a couple of months or so it will increase and it will be used for most of the strategic purposes. So the predictive value of this data is independent of time. It depends on the context of what the question we are trying to ask, how we want to use this. Depending on this, the technology we are using and the architecture we are defining will change. Next comes is how much data we have currently. Nowadays, data is everywhere. By growing technological advancements in IoT and sensors, data collected per day will increase drastically over the next few years. Data collected from source systems and applications will still be dependent on the operation size of a company, which is how best it is performing. But the other kind of data, which is operational in nature, will be which will be collected via IoT, will be exponential in the next few decades. Mostly, this data will be in real time in nature. Once we start getting insights over this vast amount of data, new opportunities will emerge and the organizations will innovate. Organizations should adapt to this change to get more insights into their data and to serve their customers much better way. By 2025, more than quarter of the data created will be in real time in nature. If you can see in this graph, so on the x-axis it is in the time frame, the y-axis is how much data we are collecting. So if you can see the strategic data which is collected through application systems and source systems is there is much change in that, but the other kind of data, real-time kind of data, operational nature data will increase drastically. Next thing to consider is the schema or structure of the data. If you can see in the y-axis, it starts from no schema or no structure or model to the highly properly modeled schema. In the x-axis, it's a classification of data on the enterprise scale. So here IoT and sensors data, which is raw and operational in nature, doesn't have any predefined or structure. So it will be much varied data structures. When it comes to social media and personal data, it is in between structured and unstructured. And if you take the classical source systems data, they are highly structured data because it's already designed in such a way with highly modeled databases. If you come to the right, so any data project will start from data marts. So these data marts are fed by the application source systems, and then these data marts will uh, collectively used to form data warehouses. And then we have master data systems wherein we gather data from social media and application systems, and we'll try to find a golden record and to achieve a customer 360. And the social media data, IoT, and sensor data all constitute for a big data. So in any organization, the maturity of analytics start from the right top corner, and the journey goes downwards to the center of the axis. So when the organizations are going towards the center of this axis, then it enables the true digital transformation. Next thing is to achieve all of these things, how do we approach the data ingestion or data loading process into the lake or warehouse or mart, whatever it is? So one of the major approaches for this is first thing is batch processing. So we do this for the classical BI solutions, where the data is from the source systems and where the data is small and it's incremental in nature. So we use a regular ETL tools for this, like Informatica, and load into the warehouses, or sometimes we do it into the lake as well. So, and another kind of data ingestion is real-time processing. So this comes in the operational data kind sources and big data solutions, where, for example, if you have any trajectories, ship routes, weathers, and environmental observations, which is not part of your regular source systems, this kind of data, where you need to process this in real time, so this will be uh, uh, streamed into the data lakes using streaming sources, using the technologies like Kafka, and will be used to derive insight in real time for the operations of the organization. And some of the other processes need both the kind of approaches together, batch processing as well as real time processing. So for some specific big data solutions and data science solution, we may require this kind of approach wherein we need the historically loaded data as well as the data generated in real time. So in these kind of situations, we'll go with the Lambda architecture. So these are the major ways of how we process the data into the analytics space. Finally, let's discuss some of the challenges of data in digital transformation. In the previous days, it was only data marts and warehouses. But now, to handle the bigger landscape of analytics, we have to look into data lakes and lakehouse architectures with the cloud technologies to get most out of the data and to get proper insights and serve the customers better. With the availability of real time and big data, we are flooded with the data, and we need to harness that with proper algorithms and machine learning programs to get best predictions out of it to help business grow, which is also a great challenge. Coming to real-time data, getting and processing the real-time data involves huge cost in terms of technology usage and scalability based on the cloud and based on the load of data the organization have. Coming to the storage, with the increased amount of data, it is more complicated than ever. By moving data across various types of storage from the providers based on the usage and planning and archiving policies to manage and reduce cost of storage has to be done very effectively. Otherwise, the cost of analytics should should go easily shoot up. Then coming to the compute. To, to perform all these big data and machine learning capabilities, obviously we need high computing machines. Deciding which one is optimum in terms of cost and performance in this huge number of tech providers is quite a good challenge. Then next comes the availability of data to all. Without making the data available to all the parties in the organization, who needs it for their decision making, starting from the C-level executives till the customer-facing operators. It cannot be considered as a true digital transformation. Data cannot be in silos. Internal democratization of data is much needed for organization growth. Organizations should really look into to achieve this. Unlike before, the question should not be asked why the data is needed. Instead, the question has to be asked why some of the person in the organization doesn't need this data. Dynamic scalability. So, to effectively managing the cost and to reduce the cost of analytics, the dynamic scalability options have to be adopted for high cost computing machines. This can be achieved using automation and data security and data regulations. With the increased security of personal data usage and retention policies like GDPR, uh, PIPDA, PD, PB, etc., organizations have to be very careful in maintaining the data as per the concerned regulations in order to skip heavy fines otherwise. And also, the data security is also a very challenging task in the current cloud age, unlike the on-prem data storage. As the last point, organizations need to invest in IoT to get as much as data possible to get more insight and innovate the operations and bring on the efficient way to serve the customers. And the blockchain has lots of capabilities in areas of security, etc., which can enhance the business and help in digital transformation. Let's discuss about some various examples of architectures to achieve what we just discussed. So we'll be discussing various perspectives of arrangement, and then we'll blend all together in the final architecture. So let's look at this classical warehouse architecture. So the example use cases for this kind of architecture is revenue reports, wage and cost reports, transit times, etc., which basically comes from the source systems or the ERPs which an organization has. And one more thing, this architecture is not like a standard. So this one is just like a example template wherein I used all Azure technologies. This can be very well be achieved using Google technologies or AWS as well, or any other cloud providers for that matter. And the same thing can be achieved with the usage of the different technologies in the Azure itself, unlike what I have just used. This is just like a template and the flow of data. So if you can see here, we have a one flow coming from application ERPs into the staging layer and going to the warehouse, and some like big data sources which have the files will get loaded into the data lake, and using Polybase or Databricks kind of computation engines will load them into SQL warehouse, and which then will be accessed via Power BI dashboards or any kind of visualization tool. Sometimes we can use analysis services if needed or not. So coming to the big data architecture. So in here, the major difference is like we should use a high computing machine like HGN said in terms of Azure. And then if this is driving some real-time apps, so we can make use of Cosmos DB. And then, so this kind of, for example, use cases, particularly in the shipping industry for this is like shipping maintenance prediction, oil spill model accuracy, real-time destination ETA prediction, etc. So coming to the data science architecture. So in here for the machine learning model, so the data can be come from the big data sources, SQL warehouse, and from IoT, social media, anywhere. And then it can be fed back to real-time apps using Cosmos DB, or maybe a report getting the insights, and maybe it loaded the data or insights back to the warehouse as well. So example use cases for this is fault prediction and proactive maintenance, optimizing and maintenance of schedule of ships, optimizations and fuel efficiency. These are the specific use cases to the shipping industry. So now let's, as I said in the beginning, now let's look at the high level architecture, building all these three. So the classical BI part of it, big data part of it, and real time and data science part of it. So next, just look at a high level view of how we can handle this setup in global and local BI setup, kind of for the organizations which uh, exist across the countries or various regions. So, so this architecture helps to set up BI in kind of in those kind of organizations. For example, if you can see here, each and every country has their own set of data and reporting solution, and there should be a global analytics space where it has its own warehouse and data setup. So by this way, the effective data governance can be achieved. The specific requirements and specific analysis and the reporting requirements of individual countries can be achieved, as well as the local managements can have access to the global reports, and everything can be validated via proper validation mechanisms using maintaining proper data governance principles. Well, that's my last slide. So, so if you have any questions, I'm here to answer now.